Hello, this is FlippedHarber for Algebra 2. In this video we're going to talk about section 5.9, operations with complex numbers. Now our objective for this lesson is to perform operations with complex numbers. The outline for the video will start by talking about what's referred to as the complex number plane. Then we'll use that to talk about the absolute value of a complex number. We'll move on to adding and subtracting complex numbers. We'll look at powers of I, then we'll talk about multiplying complex numbers, and we'll end with dividing complex numbers. Now, the complex number plane looks a lot like the Cartesian plane, the xy plane, but instead of a up and down a vertical y-axis, that's our imaginary numbers. So you'll notice all of that axis is labeled with I numbers, imaginary numbers. The horizontal axis is no longer our x-axis, that's our real number line. So if we want to quote-unquote plot an imaginary number, a complex number, we move horizontally the real number. So we would move horizontally 3 and then move vertically for the imaginary number. So the point 3, 4, we move over 3 and up 4, and here is the point 3 plus 4i plotted in our complex number plane. Now that's not real interesting, but we can use it to talk about the absolute value of a complex number. The absolute value of a complex number is based on the Pythagorean theorem, and I've gone ahead and I've drawn in a right triangle. Now this right triangle is 3 units wide, 4 units tall. So when we talk about finding the absolute value of a complex number, we're talking about how long is this line right here. So if I asked you how long is this line, you could use Pythagorean's theorem to find it. And that's what we're going to do here. So the absolute value of 3 plus 4i is equal to the square root of the real component squared plus the imaginary component squared, which is equal to 5. Okay, so let's talk about something a lot easier. Adding and subtracting complex numbers is ridiculously easy. All we do is combine like terms. So if we have 3 minus 2i plus negative 1 plus 3i, we're just going to take the 3 and add the negative 1. We'll get 2. Take negative 2i plus 3i, and we get plus I. Subtraction is just as easy. You just have to remember that this negative gets distributed to both of these numbers. So 3 minus negative 1 is 4. Negative 2i minus 3i is negative 5i. Very, very straightforward. Now let's talk about powers of I. You already should know that I equals the square root of negative 1. You also should already know that I squared equals negative 1 because the square gets rid of the square root. So I squared equals negative 1. If we multiply by I again, we get I cubed. So I cubed is equal to negative 1 times I. So that means that I cubed is equal to negative I. I to the fourth brings us full circle. I to the fourth is equal to 1. And then everything starts all over. I to the fifth is just equal to an I to the sixth is equal to negative 1. I to the seventh is equal to negative I. And I to the eighth, again, gets us back to 1. This pattern repeats and repeats and repeats. I to the 9th, I to the 10th, I to the 11th, I to the 12th equals 1. I to the 16th equals 1. And the pattern just keeps going and going forever. Alright, so we need to talk about that so that we can talk about this next big subject, which is multiplying complex numbers. Now, this looks like we're multiplying a couple binomials, and that's actually how we deal with it. We're going to use the FOIL method, first, outside, inside, last. So, what do you get when you FOIL? Well, First, that is 4 times 6 gives me a 24. Outside gives me minus 4i. Inside gives me minus 24i. And last gives me a plus 4i squared. Now, this right here is why we talked about the powers of I. What's that going to be equal to? Well, it's equal to a negative 4 because I squared equals a negative 1. So now I just combine like terms. 24 minus 4, 20. Negative 4i minus 24i is minus 28i. All right, let's do another one. Again, we're just going to FOIL. The minus 4i squared becomes plus 4i. But wait a minute. These imaginary numbers inside just canceled out, and we were left with just a regular real number. That's pretty special. These two numbers are complex conjugates. Remember that from a couple sections ago. The exact same first number, the exact same imaginary number. It's just that the signs in between are different. Whenever you multiply complex conjugates, you always get a real number. And there's actually a trick that you can use to find this real number fast. So let's talk about how to do that. If you multiply complex conjugates, the exact same complex number except this sign in the middle is opposite, it will always equal a squared plus b squared. That is your real number squared plus this imaginary coefficient squared. Always, 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 if they're complex numbers, this is what it's going to equal. Okay, now we're going to need that for our next subject. There's kind of a trick here, and it's not a big secret or anything, but it turns out that if we want to divide by complex numbers, we don't divide by complex numbers. We're going to make this bottom complex number a real number and then divide by that real number. Now the way I do that is I'm going to multiply the top and the bottom by the conjugate of the bottom. So what's the conjugate of 2 minus I? Well, the conjugate of 2 minus I is 2 plus I. And I multiply by that top and bottom. Now, I'm going through all the painstaking process here, but then we'll use our trick, and we'll talk about this, how to do this easier. There's no trick to multiplying the top. You have to FOIL this out. There's no way around the hard work here. So we'll change our minus I squared to a plus 1, change our minus I squared to a plus 1. On the top, we get 7 plus I. On the bottom, we get 5. Always turns into a nice real number for us. Now, this is ready to go, but it's just not in our standard complex number form. I'm going to break it up into two fractions. 7/5 plus 1/5 I. All right, so now it's time for you to try some of this on your own. I'll see you in class, and I'll see you online.